Okay, so we've already talked about how we can change the period and amplitude of trig functions. Today we are going to talk about how do we shift trig functions. We can do a phase and a vertical shift, and we'll talk about what those are in this lesson. All right, so before we get going, back in your Algebra 2 days, you saw this form right here. This is called vertex form of a quadratic function. And a couple of things that I wanted to highlight. If you remember, it was probably quite a while ago, but you might remember that this h value moved the graph left and right, and it was kind of opposite of what you thought. So if you said if it was x plus 7 quantity squared, you would think plus 7, that moves it to the right. Well, it actually moved it to the left 7 units. So it'd take the whole graph, the parent function here in the corner, and move it left 7. And then by the same token, this k value right here moved the graph up and down. So that was really it. And so if we look at this example here at the bottom that I have, then this x plus 2 quantity squared would actually move the graph to the left 2 units. And then this, the k value is just normal. There's no opposite of what you think or anything like that. It's just normal. So minus 3, that would move the graph down 3 units. And that shifted from the parent function there in the corner, everything left 2 and down 3. That was it. Okay, so the reason I bring this up is because we're going to do something similar, very similar today with trig functions. We already know about that the a value changes the amplitude. The b value impacts the period. Well, you'll see here, instead of having that squared in there, everything else is the same though. It says theta minus h, and then the plus k outside of that. And so this does the same thing as what it would do for a quadratic function. So it moves the graph left or right, and this is opposite of what you would think, just like with quadratic function. And the k moves the graph up or down. Okay, so this works for sine, cosine, tangent, etc. Okay, so let's take a look here a little bit more closely at the h value. What the h value does is it moves it left or right, as we just discussed. And again, it's going to be opposite of what you think. So if we look at this first problem, it says y equals sine of theta minus pi. So minus pi, we'd think, all right, that's going to move it left. But nope, this will be opposite of that. So it's going to move everything to the right pi units. Okay. Okay. With y equals tangent of theta plus pi over 4. So this plus pi over 4, you'd think right. So we're going to think the opposite of that. And so this would move everything on that graph to the left, pi over 4 units. So that's called a phase shift. And again, that will be when you're looking, it'll be inside the parentheses with the h. And that's how you'll determine whether it's moved left or right. Okay. So now vertical shifts, as we mentioned, are up and down, and that is your k value. And you're going to look here outside of the parentheses, and that will determine your k value. So this first one, y equals tangent theta plus 2, that would simply move the whole graph up 2. Okay, and then this one, y equals cosine of theta minus 4, that would move the whole graph down 4 units. Okay, well, that also shifts our midline. And when we have a regular graph, y equals sine of theta, for example, the midline is the x-axis. Okay, right, because it's between, right in the middle of that graph. That's where the graph oscillates. And the x-axis, the equation for that is y equals 0. Any horizontal line is y equals whatever that number is. So when we take this graph and we shift it with a vertical shift of plus 4 there, then every point gets moved up 4, including this midline. So now the midline is now there. And my equation for that then would be y equals 4. Okay. All right, so that's everything about horizontal and vertical shifts. Let's kind of put this together and take a look at how would we come up with amplitude, period, the shifts, and the midline equation for these two functions. So let's look at this first one. It says y is equal to a half sine of 3 theta minus 5. All right, so our amplitude, remember that's our A value. Oops, our A value right there, and so our amplitude is going to be just a half. The period, we're going to use this to help us figure that out. For sine, it's 2 pi normally, so we're going to go 2 pi divided by b. 2 pi divided by b. B is 3, so 2 pi divided by 3. I can't simplify that anymore, so that would be my answer. All right, our phase shift. This is left or right, and you'll notice in this problem there's nothing in the parentheses there, so there is no phase shift for this one. Vertical shift, that's my k value, and that's this one right here. This is minus 5. And remember, with the k value, it's normal, so that's going to shift the whole graph down 5, which would then make my equation for my midline, y equals, if we go down 5, it should be negative 5 then. Okay. All right, so how about this second one? It says y equals 4 times tangent of 2 times the quantity theta plus 2 pi and then plus 1. All right, so my amplitude is my A, so that'd be 4. The period for tangent is usually pi. My b here is 2, so we're going to have pi divided by b, which would be 2. And again, I can't simplify that anymore, so there we go. Phase shift, inside the parentheses is what I want to look at. Remember, opposite of what we think. So plus 2 pi, we would think normally to the right. Well, that's going to move it to the left. 2 pi units. And then our vertical shift will be my k value, which is right there. So that means up 1 unit. And that would make my midline, y equals 1. All right, so that's everything you need to know regarding those. In our next video, we'll talk about how to put this all together and graph them. All right, see you later.